In this video, we're going to look at how to find some attributes of a quadratic function with the graphing calculator. First thing we're going to find is the vertex. I've already put in my quadratic for my y equals, and now I'm going to go take a look at the graph in a standard window. If you don't have a standard window, just do zoom 6, and that'll always put you back in a standard window. Now the vertex is the turning point of where this thing turns around. So right now I don't see the vertex. So I want to move my window up a little bit so that I do, and I'm going to go to my y max. So let's change it to 20. And let's regraph. And there is our vertex. Notice as far as a quadratic goes, it's a maximum or a relative maximum. So we can do second, calculate. Maximum is number 4, and we're going to give it a left bound. You can see the cursor there is already on the left, and now a right bound. So we need to move our cursor to the right, somewhere to the right of that point. Now you can see we're over to the right. When enter, and when it says guess, hit enter again. And we get the x and y coordinate of our vertex, and because of the calculator uses numerical methods, this actually will round to 1.25. You could see in the other video that we were able to get it to exactly 1.25. So there's our vertex. It's given as a point. Next thing we're going to find is our axis of symmetry. The axis of symmetry is the vertical line that would cut the parabola in half, and if we were to spin the parabola around that vertical line, we get the exact same parabola. So it's symmetric about that vertical line. So it's going to be an equation of a vertical line, and in this case it's just the x-coordinate of our vertex, which is x equals 1.25. So when we found the vertex, we found the axis of symmetry. When we find the axis of symmetry, we have the x-coordinate of our vertex. Look, now the domain. Now, unless we're in a context, the domain of quadratics is always going to be all reals. As we can see, it's just going to keep on going to positive and negative infinity. The range, though, we can see there's a y value here where it caps off and goes down. Looking vertically, the highest this thing ever goes is the vertex. So the range goes from negative infinity up to the y coordinate of the vertex, which is negative infinity to 15.25, and it does include 15.25 because we can get that as an output. Now we need the X-Intercepts. We can do this with the graphing calculator. We can do second calculate, and our option number 2 is to find the zeros, which are also the roots. Now again, it asks for a left and right bound. You can see my cursor there. I need to get to the left of my 0. So I'm going to find this left one first. And I hit enter when I have my left bound. Go over to the right. That's plenty far enough. I'm to the right of my 0. I hit enter for my right bound. When it says guess, I hit enter. And I've got my first x-intercept of 0.7025624. So rounding that off, that's how we'd write our x-intercept as a point. We're going to do something identical to that to find the other one. The 0 is number 2. And we're going to have to give it a left bound and right bound again. So we go over to the left side of it. Anywhere over here is fine, as long as we're to the left of the 0. And now we got to go to the right of it. And we got to make sure we cross the x-axis if we're looking for a 0. Otherwise we'll get an error. Guess, and we get 3.2025624 as a point. 3.2026 rounding off, comma 0. Notice 0 is in the y coordinate because we're on the x-axis, so our y value is 0. Last thing we'll find is the y-intercept. Now, because the way the quadratic was written, it's just the constant term. But if we ever wanted to find it using the graphing calculator, we can do second calculate value, which is the very first selection. The y-intercept is the output when the input is 0, and we get 9. So our y-intercept is the point 0, 9. So that's how we can find all the characteristics using a graphing calculator.